Hello everyone and welcome back. In this video we are going to finish up our course and summarize what we have wrote till now. So before I finish up my course, I need to add something here inside my socket client which will persist our socket client that if the child is disconnected, we will reconnect its clients back to the network. To do that, inside our onClose function, I'll create a coroutine scope and I'll wait 5 seconds and then I'll reinitialize my socket client using init function again and using the username again. Then I'll add some logs here. Our client is connected now, and right here trying to reinit socket, and one more here, disconnected from socket server. Let's run our app now. Okay, so you'll see if we log in here, we are disconnected from the server. After 5 seconds we'll try to reinit the socket. As soon as we turn on the internet back, you can see our client is connected now right here, and if we disconnected it again, you can see we are disconnected from the server. And if we turn back the internet on again, you'll see that our client is back and connected now. So to finish our course, let's go back from top to bottom and explain that what happens here. So I do have a signaling server that is going to transfer the data between two nodes or two peers, and the data that I'm passing between them do have some types here, like if I get and start watching events, I'll forward this to my child node. So the child will realize that he has to start a call with his parent. So he will create an offer and forwards it using WebSocket to the parent. So the parent accepts the call and returns the answer to the child. So after they create a session description for each other, they will send it back using offer and answer. And after that, they will generate their ICE candidate using turn server and transfer using a signaling server to each other and set that to their peer connection. So whenever the peer connection is ready and ICE candidates are set, the connection will establish and the media streams will add to their peer connections. So they're ready to stream the video and the audio. There are some other types like end call, switch camera, and start locating or locations that we are transferring data using these type of events. So let's go back to our Android application. So right here, the first thing that we have to handle is our socket client. There is a class called socket client that will connect our child and parents to the WebSocket server using this address, which is my local address. After you can add your real web service or your real WebSocket, and we do have a listener here which does have three functions on no message, socket open and close, to notify the higher layers that are observing this class. So using anonymous class, we will initialize our socket clients, and on message, whenever we receive a message, we will parse it to our data model, which is like this, and give it back to our listener, to higher level that is listening for this message. And we do have an event called send message to socket, which will send our data to WebSocket server. And after that, we'll prepare our WebRTC client, which is here. So inside our WebRTC client, we will create our peer connection first using this function build peer connection, which will use the peer connection factory. First, we will have to initialize our peer connection factory, then we will create it, and after that, using peer connection factory, we will create our peer connection. And inside our ICE server, we make sure that we use the TCP turn servers, so we can use the cellulars as the network to transfer the data, because in some case UDP packets are blocked in cellular's network. So using peer connection factory, we will create our peer connection instance. And then using peer connection factory also, we will create our local media stream, which is here. And after creating it, we will create our audio track and video track. So after preparing our audio track and video track, we will add them inside our local stream, and after that we will add the local stream inside our peer connection. So our peer connection does have info about our local stream. So whenever it connects to the other peer, it does have the info about our stream, and it will establish the connection and send our stream to the other node. So after preparing our peer connection and our local stream, it's time to create a call or create an answer. So to create a call using peer connection, we will call a create offer. Whenever we call a create offer, a session description will be generated locally for us, and then we do have to set this as our local description. So whenever we set this as our local description, we will send it to the other node, to our parent or to child, as their remote description. And same thing happens when other nodes receive a call. So whenever you receive a call, you want to create an answer and set the received description as a remote description, and create your session description and set it as your local description and send it for the other nodes for their remote description. After switching the session descriptions, it's time for ICE candidates. So whenever an ICE candidate is generated using turn server, you want to add it inside your peer connection first and then send it to the other node, so the other node can set it inside his peer connection using these two functions. After creating the ICE candidate and switching them and setting them inside your peer connection, you will receive the media stream from the other node. So inside my repository, I do have a listener for my WebRTC client. Using this init function, I'm passing the observer to it. So inside my main repository, whenever I see an ICE candidate, I'll send it to the other nodes and set it inside my peer connection using this function. And using onAdd stream, we will receive a media stream from the opponent from the other node. So whenever we receive this media stream, we will set this media stream inside our surface view renderer, which will show our video call, which is a placeholder for our video call. So using this stream listener, we are passing this in higher layer, which is parent activity. So using this override listener, we will get the media stream and set this using addSync method for remote view, which is this surface view renderer. So we're good to go for creating the video call. And here is how all the video call process using WebRTC works. But before creating another call, first you have to make sure to close whatever you opened before to create a new instance for the new call. To do that, inside our WebRTC client, we have created two functions. One of them is close camera and one of them is close connection. So to close camera, you use video capture first to stop the capture, then you dispose the camera. So this application will close our camera, and after that we will close the connection. So first we release our local stream using dispose method and then close our peer connection. So we're ready for another call after we receive the start watching command again. So we will reinitialize all the function that we used to prepare our peer connection and our WebRTC clients again. So that's it for WebRTC clients. It's time for our location clients. Nothing too shabby. We do have a few location provider clients. which we will use to request location updates. And to do that, we are going to need a location request and a callback. So we initialize the callback. This callback is for the times that you receive a location, and this location request is the setting actually to set how does your location change is working. So we set them, and using this callback function we will send the new location to higher layer, which is going to be our parent activity again. And whenever we receive this new location right here, we will use this function to add a marker to our map view. So that's it for this video. If you didn't get the stuff, it's because it's pretty much the advanced topic. So you can watch the tutorial again and you might miss something. I promise you, if you keep watching it again, you'll realize what's going on. And also don't forget to like the videos and subscribe my channel for upcoming courses. And if you have any question, you could ask inside my comment section. I would be happy to help you guys. So thank you for watching. Until the next tutorial, see you everyone.